This lesson is on finding surface areas of polyhedrons and cylinders. Before we start the lesson, you should print this note template so you have all the examples already drawn on your page. So you can go to this bit.ly. It is case sensitive, so make sure you type in a capital S. So bit.ly/surface area 1 with a capital S. Print this PDF, and that'll be helpful in taking notes. Okay, so first of all, a polyhedron is any shape that's made with polygon faces. So that means all the faces of the solid are polygons, which includes things like rectangles, triangles, pentagons, hexagons, octagons. Any flat shape with straight edges is considered a polygon. And so if all the faces of our solid are polygons, then this is considered a polyhedron. So to find the surface area of any polyhedron, we just have to find the area of each face and then add all of those face areas together. So I'll start with this first example, which is a rectangular prism. And so we have 6 faces altogether. We have a top, a bottom, and then 4 walls. The 4 walls, we refer to that as what we call lateral area. So whenever we say lateral area, just think of the walls. And so we have 2 bases, that's the top and the bottom. And then we have 4 walls. So we'll call it the front left, the back right, the front right, and the back left. So those are our 6 faces. So that's a good idea whenever you start a surface area problem, is to write down, just give yourself a descriptive name for each of the faces. And so the top is just this rectangle. And so that rectangle area is 16. 2 times 8 is 16. So the top is 16. The bottom is exactly the same. That's why I listed those together. The top and the bottom are both rectangles that are 2 by 8. Okay, and then the front left, I'm referring to this face as the front left. And that is a rectangle that measures 8 by 4. Since the height of this is 4, 8 times 4 is 32. And then the back right is exactly the same. The back right, meaning this, is exactly the same as the front left. And so that rectangle also has an area of 32. And then the front right, that's this rectangle, has an area of 8. 2 times 4 is 8. And then the back left is also 8. And so now we're ready to add all of those up. And so we have 2 16s, and we have 2 32s, and we have 2 8s. And those are all added together, and that gives us 112. 112, and that's an area, so that's going to be in meters squared. And so that's the basic concept of how to find the surface area for really any polyhedron. We just need to add up all the faces. That one was fairly basic just because all the faces were rectangles. If the faces are a different shape, then we still have to add up all the faces, but sometimes finding the area of the faces is a little bit different. Okay, this next figure has hexagon bases. So actually, let me back up for a moment. I just wanted to mention these are the bases on this previous example. These 4 walls added together, we refer to that as lateral area. Lateral meaning the vertical walls that wrap around. So lateral area, we sometimes abbreviate that LA. Okay, so I'll try to mention that on each of the examples so we can identify the bases and the walls, and the sum of all the walls together is called the lateral area. So the lateral area in this case is 80. If we add up 32 plus 32 plus 8 plus 8, that's 80 square meters. So if you ever have a problem that asks specifically for the lateral area, it's just the walls. Lateral area means the walls. Okay, so we'll do the same thing for this figure. We have a top and a bottom, which are hexagons, and then we have, in this case, 6 walls that wrap around. So altogether, we have, let's see, that would be 6 walls plus a top and a bottom, so that's 8 faces altogether. Fortunately, the rectangular faces are all the same, so that'll make it easy to calculate each one of those. So the hard part about this one is finding the area of the hexagon. So I'm just going to draw a hexagon. It's a regular hexagon, meaning all the sides and angles are the same. Each of these sides is 12. And then this length that they give us here, that's called the apothem. And the apothem in this case they're telling us is 10.4. So that's the distance from the center to the midpoint of one of the edges is 10.4. Now the reason why that's important is because the way we're going to find the area of each polygon, in this case a hexagon, is by splitting it up into triangles. So we see that this hexagon can be made into 6 triangles. So if we can find the area of one triangle, then we'll be able to just multiply by 6. And so finding the area of this single triangle, the area of this triangle is 1/2 base times height. So that's 1/2 of base 12 and height 10.4. And so 0.5 times 12 times 10.4 is 62.4. And so that's just a single triangle. Now we have 6 of those. So the area of the hexagon is 6 times 62.4, because we have 6 triangles altogether that make up the hexagon. And so 6 times 62.4 is 374.4. So I just took that previous answer of 62.4 multiplied by 6, and I got 374.4. Okay, so now we know the area of, that would be the top and the bottom. And then we have 6 walls that wrap around. Now each rectangle measures 12 by 4. And so that is, one rectangle is equal to 48. 4 times 8, sorry, 4 times 12 is 48. Okay, and now we're ready to find the lateral area. The lateral area is equal to the 6 walls. And that's 6 times 48. And so 6 times 48 is 288. 6 times 48 is 288. Okay, and so now we're ready to find the surface area of this figure. We have 2 hexagons plus the lateral area, which is the walls. And so that's 2 times 374.4. That's that area that we got for each hexagon, plus the 6 walls, so that's our lateral area, which is 288. Add all that together. So we have 2 times 374.4 plus 288. That is 1036.8. And that's an area again, so it's going to be in square units. So in this case, kilometers squared. And that is our final surface area. Now I'd like you to pause your video and try this problem on your own. Follow the same steps that we did in the previous example. The only difference is that the base of this figure is a pentagon, so we're going to have 5 triangles instead of 6, and 5 walls instead of 6. So go ahead and see if you can find the area of the top and the bottom, and then the area of the 5 walls, and add them all up. When you're ready to check your answer, go ahead and press play. So we'll start with the Pentagon. A pentagon we can split up into 5 congruent triangles. They tell us that our apothem is 5.5. So that's the height of one little triangle. And so if I'm going to find the area of just this triangle, that's 1/2. The base is 8 times the height, 5.5. So 4 times 5.5. 4 times 5.5 is 22. So the area of one triangle is 22, which means the area of the pentagon is 5 of those. 5 triangles, which is 5 times 22, which is 110. Now we just need to find the lateral area, and the lateral area is 6 rectangles. So if we take one of these rectangles like this one, the area of that rectangle is, let's see, it is 8, with a height of 9, base 8 and height 9, and so that is 72. So our lateral area is 5 rectangles, 5 walls, which is 5 rectangles, and so that's 5 times 72. And 5 times 72 is 360. So now we have everything we need to find the surface area. The surface area is 2 pentagons, that's the top and the bottom, plus 5 rectangles. So that's 2 times 110, plus the lateral area is 360. That's our 5 walls. So that's 220 plus 360, which is 580, and that's going to be in square centimeters. Next, we're going to look at how to find the surface area for a cylinder. And a cylinder is made up of a circular top, a circular bottom, and then the wall that wraps around. If you remember when you built this solid out of paper, the wall that wraps around is just a rectangle, and we take that rectangle and wrap it around the figure. And so the height of this rectangle is 12, and the length here is just the circumference, because in order for that piece of paper to wrap all the way around this cylinder, it needs to have the same length as the circumference of our cylinder. So this is circumference, which is 2 pi r, which in this case would be, our radius is 2, so we're going to get 4 pi. And so the area of this rectangle is 12 times 4 pi, which is 48 pi. Okay, then we have the circle on the top with a radius of 2. The area of that circle is pi r squared, which is 4 pi. The area of the bottom circle is also 4 pi. So the total surface area is only 3 shapes. It's the top plus the bottom plus the wall. Or you can think of that as a circle plus a rectangle. And the area of each circle we said is 4 pi. The wall, which is also known as the lateral area, is 48 pi. So if we add all those up, we get 56 pi. And that's going to be in square inches. Okay, so surface area equals 56 square inches. That's 56 pi square inches. That's an exact answer. We also want to approximate that to the nearest hundredth. And so if you use the pi button on your calculator, never use 3.14, always get a more accurate answer by using the pi button on your calculator. So that's going to be 56 pi, which is about 175.93. If we round to the hundredths place, 175.93. And that's also in square inches. Okay, so the answer in terms of pi is exact. And then the approximation that we got on our calculator to the hundredths place, this is considered an approximation. Okay, and that's how you find the surface area for a cylinder. Now again, I'd like you to pause your video and try this one, see if you can find the surface area of this cylinder. And then go ahead and press play when you're ready to see my solution. So again, the surface area for a cylinder is the top plus the bottom plus the rectangle that wraps around to make the lateral area. Okay, so the circle, since our diameter is marked as 4, that means our radius is 2. So the area of this circle would be 4 pi, because remember, area of a circle is pi r squared, so that's going to be 4 pi. This one's also going to be 4 pi. The rectangle that wraps around it has a height of 8, and then remember, to get this dimension, that's got to be the same as the circumference, which is also 4 pi in this problem. Circumference is 2 pi r, so that is 4 pi as well. So our area of our rectangle is 32 pi, because it's 8 times 4 pi. And so our total surface area is 4 pi plus 4 pi plus 32 pi would be 40 pi. And that's in square yards. And then we want to approximate that. 40 pi is about 125.66 square yards. Okay, so again, always write both answers. Write your exact answer and your approximation to the hundredths place. And that concludes the lesson. If you need to go back and watch any of these parts again as you're working on homework problems, please do that, and feel free to email me if or visit my office hours if you need help on any of these. Have a great day.